So I want to begin by thanking Aaron and CES for having us here today and for supporting our work using this extraordinary new data set. So I'm going to talk a little bit today about some of my notable findings regarding gender differences in the use of numeracy skills at work, and how this research plugs some gaps left by previous scholarship, and how it also points us to fruitful avenues for further research using PIAAC and beyond. So first, the research void. So previous scholarship has indicated that for a variety of reasons, women are less likely than men to enter into and to persist within so-called STEM disciplines and occupations, and that's science, technology, engineering, and math. And there's been a lot of research done about this. I've just included a few citations to just give you a little slice of it. But there's been a wide swath of research on this topic, and this is really true across Western countries. So these gender imbalances in STEM are problematic for a variety of reasons. So first, studies have shown that occupational gender segregation is economically inefficient because it aggravates skill shortages and it inhibits the maximal performance of both genders by blocking their movement into professions that would best fit their personal skills and abilities. Secondly, it puts females at a double disadvantage when it comes to earnings. Women earn less than men across most occupations, and female-dominated occupations pay less than historically male occupations, even after adjusting for skill level. Furthermore, STEM professions offer a substantial salary premium. Third, this sort of imbalance in STEM contributes to a human capital problem. That is, the supply of STEM graduates in most Western countries lags far behind employers' STEM talent needs. So this previous work on women in STEM typically looks at occupational gender stratification at the level of either academic discipline or job type, or in some cases mathematical proficiency. But I began by asking, what if female workers are using numeracy skills in their jobs to the same extent as men? They're just doing it in occupations that we don't typically think of as STEM. That is, stratification by job type might not be the same as stratification by actual skill usage. So in fact, we might imagine that quantitative tasks such as performing calculations, taking measurements, and preparing charts and graphs are involved in many occupations that are not, strictly speaking, STEM professions, including occupations such as nursing or secretarial work that have historically contained large proportions of women. So PIAAC data are unique in this respect, in that they allow us to look for the first time at gender gaps in the actual use of numeracy at work, rather than using job as a proxy for numeracy work, and for numeracy use. So I look at a variety of things in this paper, but mainly I engage in two overarching analyses. So in the first section, I look cross-nationally at gender gaps in the use of numeracy skills at work, and I also look at the importance of a variety of covariates to these gaps. And then based on these analyses in the first section, I then wanted to know, well, then when women are engaging in large amounts of numeracy at work, in what jobs are they doing it? So I generated kind of exploratory lists of these jobs. Now in the second section, because it was not feasible space-wise to generate these lists for all OECD countries, in the second section I focused specifically on the United States. First, because it's the national context in which much of the work surrounding women in STEM has been done, as well as being my own national affiliation. So I use a variety of variables in this paper, but the most important one for the purposes of this discussion today is the dependent variable, which is the use of numeracy at work. You may all know this already, but respondents were asked a series of questions about how often at their jobs they engaged in a variety of tasks. For instance, calculating prices, costs, or budgets. Responses were collected using a Likert scale. And then the variable that I use in this paper is the skill use index that was derived by PIAAC study personnel based on IRT estimation procedures using these Likert items. And there's more information about the computation of this variable in the paper itself, as well as even broader information in the OECD Skills Outlook document. So, and what I found was that first, in accordance with previous literature concerning gender disparities in STEM participation, I do find that males measure significantly higher than women on the index of numeracy skill use at work, and that this is true across most OECD countries. However, I say most because this was not the case within every context, nor was it the case for every kind of demographic subslice of the population. So in this table here, the regions with gray shading are regions in which the male mean for numeracy use is not significantly higher than the female mean. So you might be able to see, but it includes the Czech Republic, Italy, Poland, and the Slovak Republic. Again, these are regions in which the male mean for numeracy use is not significantly higher than the female mean. In all other regions, however, the gender gap was quite significant. Further, we don't see men exhibiting significantly more numeracy use at work, as I mentioned, within every kind of subgroup of the population. For instance, if we look cross-nationally at the populations of those countries below age 25, or at least the employed population, we see men are performing significantly more numeracy in their jobs than women only in a few jurisdictions. And these include France, Germany, the Netherlands, and the US. And Italy, I don't know if you can see, but is excluded here. It didn't meet reporting standards for this item. But even in these 4 countries, where men are still significantly outscoring men in terms of numeracy use, the gaps are substantially smaller than in the overall population of workers. So again, these are all people under the age of 25. So women are generally using less numeracy in their jobs than men, but there are some national exceptions, and this is also not true within every subslice of the population, as this table demonstrates. So then I turn to, when women do use numeracy in their jobs, in what jobs are they doing it? So I turn my attention to the US public use file then. And among other things, I looked at the 10 most common occupations for individuals measuring in the highest quintile of numeracy skill use by gender. These are people who are performing a lot of numeracy in their jobs. And what this chart gives you a little sense of, if you can read it, and there's obviously more detailed analysis in the paper itself, is that men and women who perform large amounts of numeric tasks at their jobs are employed in some of the same job categories, such as sales. However, high numeracy skill use at work is also stratified in ways that align with historical patterns of occupational gender segregation in the United States. So women in the top quintile for numeracy use, who use a lot of numeracy at their jobs, tend to cluster within historically so-called female fields, such as secretarial work and nursing, while top quintile men are more likely to be in, for instance, construction or engineering. And this remains true even when we control for things like age or highest degree received. And these analyses were presented in the paper, but due to time constraints, I'm not going to present them here today. But top quintile women cluster within careers such as nursing and early childhood education, while men who use large amounts of numeracy in their jobs are more likely to be working in, for instance, mining, manufacturing and construction, working as engineers, computer software development, information technology, or working as mechanics. So just to summarize the findings, first, I did find that occupational gender segregation involves stratification at the skill level as well as in the category of job, as has been found by prior studies. However, these mean differences in numeracy skill use are not statistically significant within each OECD country, nor within every demographic subgroup of the population. Now turning to the United States, men and women who perform large amounts of numeracy skill use in their occupations are employed within many of the same job categories, such as sales. However, numeracy skill use at work is also stratified in ways that align with historical patterns of occupational gender segregation. Now, it's important to point out a few limitations of these analyses. First, these lists of the top occupations for men and women who perform large amounts of numeracy in their jobs are based on relatively small sample sizes and should be viewed as exploratory lists and kind of catalysts for future research. Not necessarily in the chart that I showed you today, but when we do begin to break it down and control for additional things like age and education level. However, with the release of the PIAAC US National Supplement, we will be able to repeat some of these analyses with larger sample sizes. Secondly, the numeracy scale takes into account both basic and advanced skills. So my analysis does not assess in particular whether women or men are more likely to be dealing with high-level mathematical concepts or performing advanced calculations. Third, the tasks evaluated by the numeracy scale don't align exactly with the types of skills required across all STEM occupations. So one might imagine a biologist or a psychologist, for instance, engaging in a task such as performing an experiment or evaluating a patient that is scientific but not necessarily quantitative in nature. However, I argue that both of these limitations, these last two, are also strengths, in that PIAAC's numeracy index enables a very specific and unique contribution at the level of skill itself to the literature on gender, math, and work. And that brings us to the implications of this work. First, thinking about STEM in terms of high-level occupations, such as physicist or engineer, as has been done by much of the work in the past, rather than in terms of discrete skills that can be basic or advanced, eclipses much of the numeracy skill usage that takes place across a spectrum of occupational categories. In fact, the context where the most workers in the U.S. engage in these large amounts of numeracy, these top quintile folks, are not all occupations requiring advanced or even undergraduate degrees. There are a lot of so-called blue-collar occupations in there too. These results also suggest that the notion that women are being filtered out of quantitatively oriented careers is not completely accurate. Looking at the level of discrete numeric skills allows us to see that women are engaging in numeracy skill use. In fact, in some countries and within some demographic groups, they're doing this at rates comparable to men. Somewhat paradoxically, looking at the United States, women use large amounts of numeracy relatively often in so-called pink-collar occupations, such as nursing and secretarial work, that have historically been female-dominated. So while much scholarship has focused, and importantly, on women's underrepresentation in these high-level, white-collar STEM careers, future research should turn greater attention to occupations that entail quantitative skills but don't necessarily fall under this typical umbrella of what we might consider to be STEM. Some policy changes to ameliorate gender segregation within these occupations might include career and technical education programs for students, educational institutions, employers, and employees. Such programs might be designed in order to enable men and women both to view the transferability of their skills to non-gender traditional occupations, but to also galvanize employers to identify their needs for greater gender parity and to actively recruit and retain employees across gender lines. Another result that calls for additional scholarship is the finding that within some OECD countries, there aren't significant gender disparities in numeracy skill use at work, while others have significant gaps only within particular age cohorts. Future research might focus on these countries, their particular economies, their educational systems, and their job market structures in order to unravel these jurisdictional differences. So in particular, these findings point to myriad ways in which PIAAC data might be used in the future to respond to research questions about gender and work. Future iterations of PIAAC will enable us to perform these analyses longitudinally in order to assess, for instance, whether an age or cohort explanation is responsible for the diminished gender gaps in numeracy skill use among the youngest respondents. Furthermore, with very few exceptions, very little research has actually analyzed the careers chosen by women who leave the so-called STEM pipeline. That is, they major in STEM in college, they don't go on to STEM careers. These escape routes and their appeal to women are crucial for future research and policy surrounding gender imbalances in STEM. And this is a topic that could also be explored using PIAAC's survey of adult skills. Now finally, there's much exciting work to be done looking at gender gaps in numeric proficiency and the connection between that and the use of numeracy, both at work and at home. It'll be important to travel down these multiple avenues of future research in order to better understand not only female underrepresentation in math, the sciences, and technology, but occupational gender segregation more broadly, and the ways in which stakeholders at the international, national, and local levels can really best harness and deploy the skills needed for work in the 21st century. Just a couple of acknowledgments. I'd like to thank AIR and CES. I'd also like to thank Dana Britton and the Center for Women in Work, where I'm currently employed, and I look forward to hearing all of your comments.